Welcome once again to our chemistry jam class. In our today's class, we are going to treat some past questions. So before I start, I want to appreciate your effort by keeping to the deal that's following this channel bomber to bomber. Some of you are doing like that, and I believe you have learned something. That's the reason you are following this channel like that. Keep following. So the first question for today says, use the table below to answer questions 1 to 3. Question 1 to 3. So this is the table, and they ask you to use the table. This is extracted periodic table. It's periodic table, just in a very small form. Okay, so you have group 1, group 2, group 3, group 4, group 5, group 6, 7, and 8. These letters represent elements. Now, they said you should use it and answer these questions. Now, question 1 says, which of the letters indicates elements which exist as diatomic gases? Which of the letters indicates elements which exist as diatomic gases? Diatomic gases, a gas that is made up of 2 atoms per molecule. Now, the first thing you should do, where do we have gases? These are not gases. This side are not gases. We have gases here. We have gases here, mainly these 2. Group 7 and group O are mainly what? Gases. But group O or group 8, as the case may be, sometimes they call it group O, sometimes group 8. Now, they are monatomic gases. Mono means one atom per a molecule. But group 7 are diatomic gases. Diatomic gases, meaning 2 atoms per 1 molecule. So, but if you check the answers here, the options here, they are not telling you one element. Here, already you should know that this is one of them, since they are talking about diatomic gases. F is one of them. Now, how do I get another element since there are 2 here? Come back to group 1. In your periodic table, you should remember that there's one non-metal called hydrogen that is placed conveniently in group 1. Group 1 are metals all through, but apart from the first element, hydrogen, which you can place it there as the first element in that group 1, or you place it here. Since they have shifted it to this place, so it is also diatomic molecule. That's hydrogen. So you have A and what? F as diatomic molecules in this table. Check where you have A and F. A and F. So that's the correct option to that question 1. I hope you understand what I have done there. Now let's go to question 2. Which of the letters represent an alkaline earth metals? Alkaline earth metal. Just alkaline earth metal 1. Which of the letters represent alkaline earth metal? Remember, which group do we call alkaline earth metal? Excuse me. Group 1 are called what? Alkali metals. Group 2 are called alkaline earth metals. Group 7 are called halogens. Group 8 are called noble gases. So this is alkaline earth metal, which is what? C. So number 2, where do you have C? Check. C is correct. Now let's move down to number 3 question. Number 3 question says, which of the following pairs of letters denotes elements containing the same number of electrons in their outermost shell? Which of them have the same number of electrons on the outer shell? That's what they are saying. These pairs, are they to have the same number of electrons on the outer shell? What about this? What about this? And they said none. G says none of the above. Okay, so now if we should solve this problem, we should start by knowing the position and the element that's supposed to be there. At least the number of electrons each of the group should carry on the outer shell. Remember, group 1, they have 1 electron on the outer shell, since they are talking about outermost shell. So outermost shell, this and this have the same number of electrons, 1, 1. This one is alone. The number of electrons, because it's in group 2, on the outer shell, it will carry 2. The number of electrons, because group 3, on the outer shell, any element that falls there will carry 3. The same here, it should carry 4, it should carry 5, they should carry 6, they should carry 7, they should carry 8, apart from the first element. The first element, we have duplex and octet structures in group 8 or group O, if you like to call it so. So this one, the first element in this group carries 2, because the first shell can only accommodate 2 electrons. So once those 2 enter, that shell is filled up. So this B has 2 on the outer shell. The rest of them will carry what? Because it's the second shell now. They will carry maximum of 8. So this man has 8, this man has 2. So now, which of them do you think will carry the same number? This one 2, this one 8. They are not the same. If you even have them, then let's see A and B. Let's see A carries 1, B carries 2 on the outer shell. So that is wrong. B says B and G. Where is B? B carries 2, G carries 8. So this is also wrong. Some persons may have rushed to pick that as the correct option. It is not true, because this is first element in that group. Assuming it is here, another element is here. So this and this will carry the same number of electrons. So not the first one. So this is wrong. A and C. They said A and C. I have told you this one carries 1. In this group they carry 1. This group carry 2. This group. So C has 2 electrons on the outer shell, while A has 1 electron on the outer shell. So A, B, C are wrong. So now the correct option is what? D, none of the above. So that is the correct option to that question. I believe you enjoyed following up that show. Keep on following. Okay, now let's see this question. Which of the following electron configurations represent the transition element chromium. The symbol for chromium is Cr. Atomic number of chromium is 24. So which of these is the electronic configuration of chromium? Okay, so to find this, if you do not know how to write the electronic configuration of elements, first 30 elements in the periodic table using SPDF notation, you may not be able to get the answer to this question. Remember that S orbital contains not more than 2 electrons. P contains not more than what? 6. D not more than 10. F not more than 14. Difference of 4, 4, 4. Now, so where you see 2, S, it should not carry more than 2. When, even if more electrons are still there, it can carry 1 when there's no more electron. But if you have more electrons, you put what? 2. Okay. The same with 6, not more than 6. When, even if you still have more electrons, once 6 enter, it is filled. Stop. Create another orbital. Likewise, D, 10, not more than 10. It can be below when there's no more electron. The same with F. Okay, so knowing this or having this in mind, so we can now write the electronic configuration of chromium with atomic number 24. If you check, electrons are the powers. These are the electrons in each case. You sum them up. Remember, I told you in one of the classes earlier that any element without a charge, plus or minus, the number of electrons in that element is the same as the atomic number. So the number of chromium here is what? 24. So you are going to add these 2 electrons in this orbital, 2 electrons in this orbital, 6 electrons in this orbital, 2 here, 6 here, 2 here, 4 here. Add the powers and see what you have. Add the powers also here and see what you have. Add the powers of here, add the powers. That might give you 24 each. But one is correct. When you don't know the orbitals, how to arrange the orbitals correctly and how to put the electrons, you will not still get it. Using Hubble principle, I think in one of my classes I taught that. Please go and check Hubble principle, where you have 1s, 2s, 3s, 4s, 5s, 2p, 3p, my 2 are going together, 3 are going together, 4 are going together. Since the first one was s, the second one will be what? p, all true. Then I'm done with p. I will take the third one is d. D should start with 3. 3d, 4d, 5d. Then the next one is f. F will start with 4 because it's number 4. Remember, S, P, D, F. So number 4, 1, 2, 3, 4. 1 started with S. 2, P started with 2 because it's number 2. D started with 3 because it's number 3. F is now starting with what? 4 because it's number 4. 4, F and 5F. So by the time you use this arrow, cross them this way, you will now know what to do. Take them 1s, 2s, then follow the arrow 2p, 3s, 3p, 4s, 3d, and so on till you get to the end. That's the arrangement. Now you now check, this can carry maximum of 2, this maximum of 2, this maximum of 6, this maximum of 2, this maximum of 6, maximum of 2, maximum of 10. By the time you finish up to this point, you get chromium inside. Okay, now, but this is not what I have taught this. Go back. That's the reason I'm just rushing it. I'm reminding you. But let's see how we can write the electronic configuration of chromium. Okay, so the first one, if you count the power, it will give you 24. That does not mean it's correct. Let's count first. 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18 plus 2, 20 plus 2, 4, 24. Let's see this one. 2, 2, 4, 10, 12, 18, 18 plus 6, 24. Let's see this one. 10, 12, 22, 24. 4, 10, 12, 18, 19, 24. So all of them are 24, but all of them are not correct. How do I know the correct one? Okay, now the electronic configuration up to 1 is to, let me, if I should start with scandium. Scandium is 21. Using this, 1s, 2, 1s, 2s, 2p, 3s, 3p, 4s, 3d. Let's put those electrons 2. This is the base that I want to use and work. If I am dealing with scandium, atomic number is 21. Scandium 21. I will say first shell orbital will carry 2. This one will carry 2. This one will carry 6. If you add, that's 10. You still have more left. This is 21 that we are looking at. This one will carry, because it's 8, will carry 2. That's 12. 12 plus 6, 18. 18, 20. From 21. So we have one left. 3d1. That's what you have for scandium. Okay. Now, if it is titanium, 22, you now have the same thing. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now, remember, if you add all this now, this is 20. How many are left? This is 22. 2 are left. 3d2. Vanadium 23. You have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. Chromium is 24. Chromium 24. Now let's write that one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3 instead of making 3d5, which you may be going for. Which other one? Which one? Sorry, 3d4. It's supposed to be 3d4, so that you now say that A is correct. This A is not correct. Now, remember I told you S is equal to maximum 2, maximum 6, maximum 10, maximum 14. Now, A is not correct. If you write this, you are wrong. If you go for this, you are wrong. Because this, at this point, this electron will move 1, because S can carry maximum of 2. D can carry maximum of 10. But this man is almost half. Half of 10 is what? 5. Is almost half, while this one is full. It will not happen. This man will not agree it to happen this way. Instead, it will say to S, D will say, 3D will say to 4S, guy, you are full, and I am almost half. Why not you borrow me 1 to make my own half, while your own is also half? So 4S has no option than to donate 1 electron to 3D, making this place to be half of 2, which is 1, making this place to be half of 10, which is what? 5. So that it will be able to be stable. At this level, this atom is stable. So this is the correct electronic configuration of chromium. We call this anomaly. It is different from what it's supposed to be. You saw this, how we got this, how we got this, how we got this. But this place was not like that. Anomaly. The thing changes from the usual way. So that's anomaly. Now, this is the correct one. If you have gone, this is the correct one. If you have gone for this, you are wrong. If you have gone for this, you are wrong. If you have gone for this, you are wrong. So, study it and keep following the channel. I believe you are enjoying the class. Now let me give you a problem to solve. Okay, your assignment is using SPDF notation, write the electronic configuration of copper atom. Copper atom. The atomic number of copper is 29, and zinc atom, the atomic number of zinc is 30. So just use the same method that I did, I just finished using, to write that of copper and write that of zinc. That's what I want to see. Then drop it on the comment section. Thank you for following the channel. I believe this channel has been a blessing to you. Keep on following it. Subscribe to it. Invite your friends to keep following the channel. If you really want to make it high, you want to make it big in your jam that is coming up soon. Thank you, and then remain blessed till we meet again. See you